All right, guys, this is going to be probably our last experiment. We'll look things over Thursday night and see where we stand. But what we're going to do is convert the molecule carvone, which comes in two enantiomeric forms. Carvone comes in the R form. It's going to smell like spearmint oil. And the thing is, some of it interconverts back and forth. So we have both the R and the S carvone. And that's in caraway seeds, like rye bread. Uh, some people say it smells like a pizza or something like that. So it doesn't really matter in the case of what the molecule is that we're going to form, which you should be able to find pretty quickly or pretty easily. This is a pretty common experiment that's done. Our scenario tries to hide the fact of what it's going to produce, but I think you should be able to find. And actually, I ask you to do that on the quiz, is to find out what this is going to make. So we're going to do the acid catalyzed, and it's going to turn out that we're going to use the acid to catalyze this experiment. And we're also going to use the acid as the solvent for the experiment. So it's going to have a dual role. But it's not really going to matter what you use, the R or the S, because it turns out that the product is going to be achiral. So it really won't matter which isomer you use. It says that R will be used. I have a bottle of S. You may pick either one. If you prefer rye bread smell over minty spearmint smell, then be my guest. The product should have a totally different smell than either of those. So you should be able to definitely tell the difference between the two. It's a multiple step reaction. The first part is going to be acid catalyzed enolization of the carbonyl moiety, which is it's reversible. And typically what happens is the keto form of it is favored. However, the fact that we use the acid shifts the equilibrium towards the enol form. And it turns out that in this reaction, it turns out to be the more stable product. But it's more stable than usual. Usually the other form is predicted to be the version you want. Now you're going to be looking up the steps and you should be able to find multiple sources of the entire mechanism for this. As a matter of fact, I'm pretty sure you can find videos of this mechanism. And then in the second part of the reaction, you form a carbocation that gets rearranged and deprotonated and makes, what happens is the carbocation rearrangement occurs through a hydride shift. And you're going to end up making a very stable carbocation intermediate. And then that carbocation intermediate will go ahead and complete itself and deprotonate and form the final product, which is a pretty famous product in its own right and is a very major component of a commonly used spice in the Italian world. So I think you can kind of go off of that, and that should be enough clues that you should be able to get that. We will use reflux. We will use liquid-liquid extraction. We will isolate the product, and we will take the IR, and we'll compare the IRs from the beginning and the end to see what kind of functional groups we have made. These are not your directions that I'm using here, but they are pretty close. You're going to be I believe we're going to use even the smaller round bottom flask, but if it's not the 100, just go by your directions. We're going to make one modification. Don't go by these amounts. So you'll add your carvone and with a stir bar. You'll add your 6 molar sulfuric acid, which remember, dual purpose, catalyst and solvent. Set up your reflux. You're going to reflux that for about 45 minutes. Once it's complete, allow it to cool while still stirring, and then put it in an ice bath to complete the cool down process. Transfer that to the separatory funnel. Here's where we're going to make the difference. Your lab says use whatever our amounts are for petroleum ether, change it to diethyl ether. The ether will evaporate a lot easier than petroleum ether, and it won't smell like gasoline in there when you get rid of the solvent. Remember, be careful with the ether. You kind of get that narcotic effect. Now, be careful. Make sure you know which layer's which here. Check your densities, especially with the ether. That should help you. Check your density of, remember, 6 molar sulfuric is going to be in a water solution. So check the density of ether. Look that up. Make sure you know which layer's which. Now remember, you're extracting the solution twice and then combining the extracts. So you want to try to get as much of the material out of the water layer as you can. So keep the first extraction, then put in another round of the diethyl ether, extract again, combine the 2 ether extracts, and then put in sodium bicarbonate solution. You got to be a little bit careful there. Notice what it says. Let the bubbling subside before you start shaking. If you don't, you may blow the thing up. This one is going to produce quite a bit. Remember, you got acid in there, and it's a catalyst, so you're going to get it back at the end. So you're going to have to get rid of all that acid that you put in there with the sodium bicarbonate. And then it says wash. Here it says brine. You're going to use a sodium chloride solution to make those 2 layers. Obviously, we can separate your product away from that. And then dry with sodium sulfate or magnesium sulfate, whatever we have out there. And then transfer it to, it says a round bottom flask here. We do not have a rotary evaporator. Wish it was. We do have one, but we only have one. And by the time everybody used it, it's a pretty cool device. So you will just very simply, in a hot water bath, in a beaker, will probably be the easiest. Sit there. You might want to run a little air, but be careful. The boiling point of your liquid is tremendously different than the boiling point of ether. And remember, a hot water bath should be enough to boil the ether off. So just have a nice hot water bath. It could probably just be warm water. You could probably get by with hot tap water. And then get the IR of it. It says get an NMR of it. I will provide you with the NMR, and then I will allow you also to see what has happened to some of the functional groups and the movement of them. Don't worry about step 15. We're not saving it. We will not use it in another experiment. There's some other things you can do with it. I will provide you with the questions that day. I don't remember what the question numbers are. And of course, I don't have my book with me at this time. So we will see you on Thursday. Lots of nice smells Thursday night. So you investigate, go look up what it's supposed to make and look up the mechanism. There might be a couple questions about the mechanism and what you're going to make on the quiz. So be prepared for that. See you then.